Hi there, this is Ms. Page, and in this lesson we're going to talk about what we call the sum and difference identities. The sum and difference identities are trigonometric identities that allow us to find the exact values of the sine and cosine of some non-unit circle angles. Specifically, we can find the exact sine and cosine values of angles that are the sum of two unit circle angles or the difference of two unit circle angles. For example, if we take in our first quadrant our pi-4ths radians and our pi-6ths radians, if we subtract these two angles, what we get is a new angle of pi-12ths, which is shown right here, which is equivalent to 15 degrees in degrees. 15 degrees is not an angle in one of our special right triangles, so it is not a unit circle angle. However, a difference identity allows us to find the exact value for either the sine of 15 degrees pi-12ths radians or the cosine. And if we add pi-4ths and pi-6ths together, we get 5 pi-12ths, which is shown here, which is equivalent to 75 degrees in degree measure. So a sum identity would allow us to find the exact sine and cosine values of 5 pi-12ths radians, which also is not a unit circle angle because 75 degrees is not an angle in one of our special right triangles. So that's what we're looking at today. So here is for reference the sum and difference identities. Now at this point I want to clarify as far as what you are expected to learn without having a reference sheet. So earlier we've talked about our reciprocal identities, such as the sine of angle theta equals 1 over cosecant of theta, or that tangent is equal to sine over cosine as a quotient identity. And so those identities you are expected to learn and not need to look up. Also, your Pythagorean identities, your sine squared plus cosine squared equals 1. That is an identity you should learn and not have to look up. But the sum and difference identities, at this point in time, it's not required that you learn or memorize them. They would be given to you for a reference when you needed to use them. So you have to know which one to use and how to use it accurately. So we have four. We have sine of a sum of two angles, here called alpha and beta. We have cosine of a sum, alpha and beta. And then we have our difference identities, a sine of a difference and a cosine of a difference. All right. So what you want to do first is when you have a non-unit circle angle that you want to find the exact sine or cosine value of, that you can use a sum or difference identity on. Not all will work this way, but if we go back, what you're looking at, that what works for these are all of our 12s. So these angles are all the angles that we can use a sum or difference identity on to find exact values for sine and cosine ratios of those angles. So you want to figure out what sum or difference of unit circle angles will equal the angle you're working with, and then you want to make sure that you know which identity that would correspond to and what that would be, and then you have to make sure that you understand that your unit circle angles that you've added or subtracted would be your alpha and your beta. And you plug that into both sides. So alpha is pi-4ths, then we put pi-4ths in each of our alpha positions. If beta is pi-thirds, then we put pi-thirds in each of our beta positions, and so on and so forth. Then we have to know our unit circle values, our sine and our cosine values for those unit circle angles, and we replace sine of pi-4ths with its value. We replace cosine of pi-thirds with its value. that kind of idea. And then we use our basic math skills to simplify, which basically will come down to multiplying with ratios, adding and subtracting fractions, getting a common denominator when necessary, that kind of a thing. Usually, though, we'll look at the basic math. If we're smart about it, we won't have to get a common denominator, but we might have to reduce at the end. And then that would give us our final answer, that simplest form. All right, let's take a look at a couple problems. So here we are going to find the exact value. So again, this is a no calculator type of problem of the cosine of pi 12ths radians. So the first thing that I want to do is figure out which two unit circle angles I can either add or subtract to get this pi 12ths radians. Now pi 12ths is 1/12 pi. That's a small angle. So generally speaking, I would be looking at a subtraction in this case. The way that I do it is not by directly using my unit circle angles, but by using angles that have a denominator of 12ths. So for example, I need pi to have a coefficient of 1. So I'm looking for two numbers that have a difference of 1. Because I'll have pi here and I'll have pi there. And then, for example, I could use 3 and I could use 2. Now, not any numbers will necessarily work. So there's something else that has to happen here, which we're going to talk about in a moment. But 3/12 minus 2/12 would be 1/12. And then I've got my pi in there too. And so that works. What also has to be true, though, is that these angles either have to be equal to unit circle angles or reduce to angles that we know are part of our unit circle. So 3/12 is 1/4, so that would be pi 4ths. Pi 4ths is a unit circle angle. 2/12 reduces to 1/6, so that would be pi 6. That is a unit circle angle. That tells me I can use these two angles, or this difference, to find the cosine of my pi 12ths radians. So now I'm going to find the cosine of my pi 12ths radians. That would be the same thing as the cosine of the difference of pi 4ths and pi 6. So now I need my identity for cosine of a difference because I'm doing a subtraction here. So going to our identities, cosine of a difference would be this one. Now I want to point out a couple of patterns that do kind of make it, if you had to memorize these, possible to memorize them. So notice that sine identities both start with sine alpha, and then it switches to cosine of the second angle beta. And then the operation here matches the operation in the sine. Subtraction matches subtraction. And then from sine alpha on this side, it goes to cosine alpha. And from cosine beta, it goes to sine beta. And same thing here, cosine alpha, sine beta. For cosine, notice that they both start with cosine, but it's double cosine. So it's cosine of both of the angles. And the operation here is the opposite of the operation there. And then we have the two sines together. So with a little bit of practice with these identities, they have patterns in them that you start to notice and be familiar with, and it makes it easier to memorize them if necessary. We are using this one, cosine of a difference. So we have our two cosine product, then the opposite sign of addition, and then our two sines. So that's what I'm going to write out here. So I have got here my cosine of a difference. So I'm looking at cosine of alpha minus beta would be cosine alpha, cosine beta, opposite sign, so plus, sine alpha, sine beta. So what I have to realize is that my alpha is going to be my pi 4ths, and my beta is going to be my pi 6. So when I write cosine of alpha, that's my cosine of pi 4ths, this part, times cosine of beta, which is pi 6, and then plus sine of alpha would be sine of pi 4ths radians, times sine beta, which would be the sine of pi 6 radians. So now what I'm looking at doing is using my knowledge of the unit circle, and hopefully again you are getting familiar with that. So now we need to replace each of these 4 with the value that they're equal to. So we need to know that the cosine of pi 4ths radians is root 2 over 2 times the cosine of pi 6 radians, which is root 3 over 2. Then we have our plus. Sine of pi 4ths radians is root 2 over 2. Sine of pi 6 radians is 1/2. So now order of operations says that I would multiply before I add. So multiplying straight across, square root of 2 times square root of 3 would be the square root of 6. 2 times 2 would give me 4. This would be the square root of 2 over 4. So I have a common denominator. So my final answer is going to be all over that common denominator of 4, and the square root of 6 plus the square root of 2 becomes my numerator because they are unlike radicals, so they cannot be combined. So my final answer is that this is my exact value of the cosine of pi 12ths radians, like so. All right, let's take a look at another problem. So here in this one, we're looking at finding, again, the exact value, so no calculator, of the sine of 17 pi 12ths. So again, I'm going to look for 2 angles that will either add, from my unit circle, that will either add up to 17 pi 12ths or subtract to give me 17 pi 12ths. 17 12ths is 1 5/12, so it's kind of a large angle as far as in the first revolution. So I might look for adding in this case, but as long as I find 2 angles, it doesn't really matter. So the first thing I'm looking for is taking my 17 pi 12ths, and I want to find 2 angles, and I'm going to try addition here, that will add up to, and then I have to make sure they're unit circle angles. So I'm looking for now 2 numbers that would add up to 17. So I might try, for example, say 9 and 8. 9 plus 8 being 17. Now, as long as I said, each of these reduces to a unit circle angle, verifying they're part of the unit circle, then I can use them. So 9 12ths is 3/4, so that would give me 3 pi 4ths. That is a unit circle angle. And 8 12ths would reduce to 2/3, so that's 2 pi 3rds. That is also a unit circle angle. So I could use these 2. They may not be the only 2 that I could use. There might be other combinations that could work also that are unit circle angles. As long as they give you the right sum or difference, your 17 pi 12ths in this case, and they are unit circle angles, then you'll be able to use them. So now I have to realize I am now finding the sine of this angle 17 pi 12ths, the exact sine value, and I'm looking at a sum of 2 angles. So I'm looking at my sine of 17 pi 12ths would be equal to the sine of these 2 angles added together, 3 pi 4ths plus 2 pi 3rds. So that means that my identity I need to use is sine of a sum, because I'm adding these 2. So I can go back to my reference here. So sine of a sum is this first one here. So I'm looking at sine of the first angle, cosine of the second angle, plus, just like it is here, and then it switches and does cosine of the first angle, sine of the second angle. So I'm going to go back and write that down for reference. So I have got here the sine of alpha plus beta is the sine of alpha times the cosine of beta, same sign plus, and then it switches to cosine of that alpha angle times switches to sine of that angle beta. Now I have to realize at this point that my 3 pi 4ths is my alpha and my 2 pi 3rds is my beta. So this is going to become sine of the 3 pi 4ths times cosine of beta, so cosine of 2 pi 3rds, and then plus. And I have cosine of my alpha, which is my 3 pi fourths. So cosine of 3 pi fourths times the sine of the beta, 2 pi thirds. Now what I have to do is recognize that I have to replace, knowing my unit circle, each of these 4 with the value that it is equal to. So my sine of 3 pi fourths. 3 pi fourths is in my second quadrant. Sine is y, so this is positive, root 2 over 2, times cosine of 2 pi thirds. 2 pi thirds is also in my second quadrant. Cosine is x, and x is negative in the second quadrant. And 2 pi thirds has a cosine of negative 1/2. Oops, there we go. Then we have our plus sign. Now we need cosine of 3 pi fourths. Now 3 pi fourths is, again, second quadrant. Cosine is x, so this is going to be negative. So that would be negative root 2 over 2 times sine of 2 pi thirds. Again, second quadrant. So sine y is positive, and that would give me a positive root 3 over 2. So now I follow my order of operations. So I am looking at here, doing my multiplication next. So multiply straight across. This is going to give me negative square root of 2 over 4. Plus, this is going to give me negative square root of 6 over 4. So I've already got that common denominator of 4. And this would be the negative square root of 2 minus the square root of 6. And this would be the exact value for the sine of 17 pi 12ths. All right, we're going to try a practice problem now. So pause your video, give this problem a try, finding the sine of pi 12ths radians. All right, let's take a look at the result. So in this case, you hopefully came up with square root of 6 minus square root of 2 all over 4. Now, you may or may not have used the same angles. This uses pi fourths minus pi 6, you can see here. So this becomes sine of a difference, which is equal to this. So pi fourths is now my alpha, pi 6 is my beta. So my alphas all become pi fourths, my betas become pi 6. And then I use my unit circle on each of these 4 values, which makes them become those. And then doing the multiplication and getting it all into over its common denominator gives us that final value. All right, let's try another one. Pause your video here. We're going to find the cosine of 17 pi 12ths. All right, let's take a look. So here, you may or may not have used these particular angles. Here's our 9 pi 12ths plus 8 pi 12ths. Which gives us our 3 pi fourths and our 2 pi thirds. Here's another option, 15 pi 12ths plus 2 pi 12ths, which gives us 5 pi fourths and pi 6. So as you can see, there are, in some cases at least, more than one option. So we are finding an exact cosine. In both of these, it's a sum of 2 angles. So we're looking at cosine of a sum, which is equal to this. So our using this example shows using our 3 pi fourths and 2 pi thirds. So 3 pi fourths would be your alpha, 2 pi thirds your beta. So each of your alphas becomes your 3 pi fourths, each of your betas becomes your 2 pi thirds. Then use your unit circle and replace each of these 4 with the value they're equal to, which is negative root 2 over 2 and negative 1/2, because 3 pi fourths and 2 pi thirds are in the second quadrant where cosine x is negative, and the signs are both positive. And then that gives us root 2 minus root 6 all over 4. All right, there's another one here for you to try. This time we're going to find the sine of 5 pi 12ths. Pause your video here and give this one a try. Let's take a look at it. So in this case, a couple of options at least. This one gives you a sum of 3 pi 12ths and 2 pi 12ths, which reduce to pi fourths and pi 6, which are unit circle angles. Also, though, this is a difference, the 9 pi 12ths minus 4 pi 12ths. 9 pi 12ths gives you 3 pi fourths. and 4 pi 12ths gives you pi thirds, which are unit circle angles. This example is worked out using the sum, so sine of a sum. If you did this, you'd have to make sure you use sine of a difference, which is a different identity. Same thing here, but that would be a minus. And so in this case, what we're looking at here is our pi fourths would be our alpha, our pi 6 our beta, and so each of the alphas becomes pi fourths, the betas become pi 6. Each of these 4 values now, we use our unit circle. So they're all first quadrant angles, and so everything will be positive. So we see all of our values, do the multiplication, put it all over the common denominator, and hopefully you got root 6 plus root 2 all over 4. If you got root 2 plus root 6 all over 4, hopefully you realize that's equivalent because adding 2 numbers together, the order doesn't matter. That's our commutative property. And so if it ended up being like this, that's perfectly fine also. All right, that ends this lesson. So give your assignment a try and have a great day.